Hello everyone, my name is Jose Lara and I'm very excited to show you this demonstration which addresses many problems and solves them in an elegant way. First, we have an app on iPhone, Android, and the web, all running in under 150 lines of code, which has an AI chatbot powered not by OpenAI but by Mistral in this case. Could easily be done with OpenAI through this platform that I will be demonstrating. Not only that, but it also addresses long-term memory and gaining new memories in an episodic way by AI agents. So let's get started on the demo. First, I asked this agent, hello, I want to tell you about this video I am making. I will demonstrate giving chatbots long-term memory. And what it says is, hey there, sounds like you're cooking up something bananas. I'd be happy to hear more about your video project and how you plan to give chatbots long-term memory. Just remember, when it comes to chatbots, a banana a day keeps the forgetfulness at bay. So let me now ask, just for demonstration purposes, do you remember about my idea about a video? And let's see how the chatbot replies. Oh, my dear friends, I do recall our delightful chat about a video. You were pondering the idea of creating a video featuring bananas. Well, no, the video was not about bananas. It was about giving chatbots long-term memory. Now, what happens if I store this conversation utilizing the same under 150 lines of code to include this conversation in the long-term memory of the chatbot? These are the two same banana chatbots, and let's ask, are you sure? And let's see. My apologies, I may have forgotten the bit carried away by my banana excitement. Let me take a closer peek at our conversation. Ah, yes, you were discussing a video project involving chatbots and long-term memory. Incredible. As you can see, we can create long-term memories for our chatbots, and now we can go and just demonstrate the same thing here. We're just gonna paste it. We're gonna do it for Android. And yes, it does remember indeed, giving chatbots long-term memory. So how did this come to fruition? On our demo project, we have some SDKs we've added, some API keys and IDs of these elements we're using. We have a simple setup to a Flutter application, and then we define the messages. We create a new session ID so that we can log and monitor the chatbots each session. We just have a bool controlling the UI to show a loading screen. During init state, we will begin with a new session ID and new messages with the option to refresh. Then we have a button which stores the conversation in the vector database. And for the meat and potatoes, we have LLM chat, which contains everything, has a loading indicator, has some messages, and has a submit function, which includes the message that the user has just inputted, adds it to the history, and then begins to stream out the agent messages. Streaming is extremely important when it comes to utilizing LLM, because if the response of the chatbot is very long and you are waiting for a future, then the user is going to get a huge amount of lag time, and we certainly do not want that. When working with LLMs, whether you're working with Flutter or any other programming language, streams are the way to go. So then we just simply listen to the response. The response will contain the entire chat history plus the new tokens, the new conversational messages coming through, rebuilding the UI at each step. So this code is not perfect and could be optimized, but it is an excellent demonstration as to how working with this LLM lab allows you to easily manage chatbots and integrate them into your Flutter app and different kinds of apps as well. But Flutter to me is just the best example of how it can be used in a comfortable way. So let's check it out. Go to demo agents. Here we've made a few agents, and the one displayed in this video is actually, so the AI agent is Jose's Bananas agent. It's a helpful and friendly, whimsical assistant ready to help with any problem. Just as a description, personality, and most important of all, has a reference to a vector database, which is part of LLM Lab. Is basically a collection of data which can be retrieved based on similarity. And so when the user sends a message, we check upon that similarity and we return the top most similar results based on cosine similarity. Sounds complex, but LLM Lab makes it extremely simple. Here we can add one, and we could also make lots of different databases to test many different things out and just include them here in the system prompt to augment our chatbots. Just to take a quick look at an exploration of the database manager, we can see here it has our conversation history just added all in one chunk. And however you want to add these guys, it is based upon what you decide. In this case, we are segmenting the conversation here just based on the message, but each session could be its own episodic memory. You could decide how you want to add this data to the database, and in this case we see here it's as simple as calling the SDK, calling up certain vectors with the ID and the segments in a string format, and that's basically it. We even get a success as a result dot is right or dot left in order to handle whether or not you got a successful response. So that is basically all there is to this, and LLM Lab allows you to monitor your agent's responses, also add your documents and decide how you may want to segment them. It has a testing center which allows you to test your agents, have them chat with each other, as well as test how they chat against a data set of questions. A question and a validator. More on that, there's other videos, and these things can also be generated with AI as well and with other agents you may want to create. So thank you guys for watching. Please create an account. The first few people who join will get a generous free tier for you to enjoy using this platform with your API key. So thank you guys for watching. Let me know if you like this video, and feel free to give me a challenge as to what kind of amazing thing we can do with LLM Lab.